Okay, so we are going to do the surface integral where s is the hemisphere x squared plus y squared plus z squared equals 4 and z is greater than 0. And since we have a sphere here, or half a sphere, it's very convenient to use spherical coordinates on a question like this. And by spherical coordinates, I mean we can recast or define r of phi comma theta to be, because we're trying to parameterize this curve and we parameterize it using spherical coordinates. So this is 2 sine theta, 2 sine phi cosine theta, and that's in the I component, and then the y component will be which is the y in spherical coordinates. It's rho times sine phi times sine theta, and rho is 2. So this here is rho squared, so that means rho equals 2. Okay, 2 sine phi sine theta j, and then z is just 2 cosine phi. Rho cosine phi in the k. And then what we do on the next step is we take the partial derivatives, one with respect to phi, because what we're after here is we're trying to claim that the surface integral is the same thing as the double integral on region D, which I will define in a moment, times the cross product of r phi r theta, magnitude of that cross product, multiplied by dA. One moment here. We are missing the f. One. Let me move this here. Okay. This is of course multiplied by f of r of phi comma theta. There we go, where f is the function defined in the question as x squared z plus y squared z. Okay, so let's start by taking the partial derivatives, r phi. So we hold theta constant, we differentiate with respect to phi. So we get minus cosine phi is cosine, so this is 2 cosine phi cosine theta. I'll write it in a vector format, and this is 2 cosine phi sine theta, and the last one is just negative 2 sine phi. And likewise, we can write r theta in that same So now hold phi constant, differentiate with respect to theta. So we get the first one will be negative 2 sine phi sine theta, comma 2 sine phi cosine theta, and the third one is 0 because there is no theta in there. Okay, and now we can take the cross product of those two vectors, and then when we're done, take the magnitude of this cross product. I will not work out the details of the cross product because that's really basic math. You can see my other videos on that if you need help, but I will write an answer here. The magnitude of the cross, of course, the cross product will be a vector, and then you take the magnitude of that vector, and it turns out to be 4 sine phi. And now all we have to do is plug everything back in. So our original integral is s x squared z plus y squared z ds. So we can turn this into 4. So now we replace x with its value in spherical coordinates, rho sine phi cosine theta. So x squared becomes, and I can factor the z out of these two. So we have 4 sine squared phi cosine squared theta plus 4 sine squared phi sine squared theta times z, which is 2 cosine phi, and this is of course dA, and in this case will just be d phi d theta. And since we are going according to the question says z is greater than 0, and this is the hemisphere. That means our theta is going from 0 to 2 pi because we're transversing a complete circle, but our phi only goes down to the xy plane where z is greater than 0, so it goes from 0 to pi over 2. And notice here, if you factor out 4 sine squared phi, you get cosine squared plus sine squared, which is 1. So this really runs you down to just 4 sine squared phi times 2. We can pull this 2 out. We can also pull this 4 out. Cosine phi d phi d theta. I have a feeling I'm forgetting a... Oh yeah, we forgot the cross product term that goes here. So the cross product term was... let me actually just put it here, be nicer. Let me remove this. Let me undo that. Sorry about this. This is taking long. Let me just erase it, be quicker. Okay, so the cross product term turned out to be 4 sine phi, and then we got a cosine phi times 2. So let's put the 2 here, and then we have d phi d theta. Okay, and so then as such, this becomes a 3, and then we have 4 and 4 is 16, so we can just erase this and put the 16 right here next to the 2, and then we have d phi d theta from 0 to pi over 2, and this is from 0 to 2 pi. And this is a fairly straightforward integral to evaluate. You could just call u to be sine phi, which will make cosine phi d phi to be du. So u substitution is sufficient. I will not go through the details, but as you can see in the original question, the answer is 16 pi after you carry over the integrations. I hope this helps. Please don't forget to subscribe and like. I need your subscription to expand this channel and take it to new limits.